on moderation and mediation, and I'm Summer. So today I'm going to talk about the differences first between moderation and mediation. So essentially, I have here the two different models. So moderation and mediation both exist so the moderators and mediators both exist as a third variable, although there are many differences between the two. So moderation is the relationship between the independent variable and the dependent variable that are dependent on the third variable, otherwise known as the moderator. So first I want to reference Barron and Kenny in 1986. They basically said that researchers use moderators and mediators interchangeably, but they are essentially quite different. So both are considered third variables, but the moderator can be qualitative and quantitative variables that affect the direction and or the strength between an independent or a predictor variable. And basically, for the mediator, there's a causal relationship, as you can see here, from x to m and m to y, as well as x to y, and the independent influences the dependent variable of interest. I also want to reference Kenny. They went back to Barron and Kenny from 1986, as well as other researchers, and they discussed 4 steps for mediation. One is to show the causal variable is correlated with the outcome using y and x, as you can see here. They mentioned that 2, to show causal variable is correlated with mediator, and to show mediator affects the outcome variable, and 4 is to establish that m completely mediates the x to y relationship. So basically saying that C prime has the direct effect, which equals 0. For Preacher Hayes in 2008, there was a mention that bootstrapping is a method that involves sampling repeatedly, so resampling essentially from the data set and estimating the indirect effect per set. So this is what mediation essentially does. So these interactions are typically seen to be collinear, and the power is typically an issue, but this is an issue of hand that we typically like to analyze, and we also wanted to diminish collinearity. It's a good idea to center our variables as well to create an interaction and the primary predictor and interaction between the moderator, but not a primary predictor and the moderator. So first I did moderation, and here I did a sample size of 10,000 with an x2 and x3 that I changed from continuous to dichotomous, and a y with x2 plus x3 with an interaction of x2 times x3. And from here you can find the significances for the moderator using hierarchical tests as well as hierarchical regression, as well as simple slope and intercept, in which the regression of an outcome y on the predictor at the specified value of moderator is created. And here I have my coefficients table. It was basically is a breakdown of the standard error, the t-value, and the significance of x2, x3, and the interaction. And then I have my output here, which shows the residuals, the coefficients, which similarly shows the estimate, the standard error, and the t-value. So here's the intercept as well. And we can see here that there, for x2, x3, and the interaction, there is a significant effect. We also see the multiple r squared, otherwise known as the variance, to be 0.7204, which changes to an adjusted r squared of 0.72, and a p-value of less than 0.05, which is good, meaning it is significant. So I also chose to plot the interactions, or plot the x2 and x3, the interactions. For the normal QQ plot, you can see that there are outliers, so 9,673 is an example of one here. And here are all the different plots, as well as the residuals versus fitted, and then you can see the y-hat fitted values, which is y-hat, and our scale location here. And then you can see that you want to check for homoscedasticity on the residuals versus leverage plot, and it is a funnel shape. And it also accounts for Cook's distance as well. So I also decided to plot the interactions for our first moderation model. Here you could see that there is the interaction between x2 and x3, where x3 by the blue line shows it is equal to 0, and the yellow line shows when x3 is equal to 1. And I also decided to do a scatter plot for both x2 and x3 to see if it was linear. For x2 is actually a lot more linear than x3. As you can see, is a lot more distributed horizontally for x3. So there was the interaction as well as B1 and B1 times B3 for the next two models that I decided to do or conduct, with the continuous versus dichotomous and binary. So there were different scales essentially. For my first one, or my second one here that I have, it's x2 times x3 for my first linear model, and then x2 plus x2 times x3, which is my interaction for the third model that I conducted for moderation. And similarly to the previous model, we have our outputs here, starting with our residuals and then our coefficients. Here you can see that the significance for x2 and x3 are a lot higher than 0.05, 0.25, and 0.87, but the interaction was significant. We also have a low r squared of 0.33 with a p-value of less than 2.2 times to the negative 16th, and then we also have our output for the second one with a multiple r squared of 0.67, which is a lot higher than the second one here, as you can see. And it was shown to be significant for the x2 as well as for the interaction. So then next I have my mediation that I decided to conduct. I chose to do a sample size of 100, and I had an x variable, an m variable, which is my mediator, and my y. So these were the variables that I used, and I showed the causal mediation analysis by conducting a mediation function with a package in R. And this basically bootstraps, it shows a non-parametric bootstrap confidence intervals also, as well you can see here. We have a CME, which is average causal mediation effects, which shows indirect effects, as well as the simulations. And we have our ADE, which is our average direct effect, which shows in the plot here. And then we also have our total effect overall, and that is also shown in the output. So for ACME and for total effect and the proportion mediated, you can see that there's significant effect, but not for ADE. And it also shows here the sample size that I used and the simulations. So I also decided to plot these as well, similarly to the moderation. This is for my first mediation linear regression model, and I can see here that there are some outliers. For example, 21 and 89 are both outliers here in our normal QQ plot. And then we have our residuals versus fitted as well. And then we have our residuals versus leverage with our Cook's distance to see if there's homoscedasticity, and then our scale location. You can see that is quite distributed. And this was for our mediation model of the M onto X. And then here is what I did for my two different mediation models, and I decided to put them in a scatter plot to show how linearity. So here we have our two different comparisons for the orange line and the pink line, and this was for X and M, and then X plus M and Y. So Yeah, these were essentially the mediation models that I did. Some implications that I can discuss would be for the actual data set, if there was to be a creation of another data set, I could end up naming naming my variables in order to come up with something that is more relevant to science and something that I want to test. I don't want to omit any relevant variables because of the moderator effects. This could result in an incomplete model. So I would need both X and M for my correlated errors. And then there's also this existence of the partial versus full mediation. So full mediation is basically when C hat is maximized, and there could be no significance when C hat is equal to 0. Mediation also generates an outcome at the desired level. So this was the difference between moderation and mediation and regression. And thank you.